What's happening in class? Today we're going to talk about circles. And circles of the conic sections are probably the easiest. I don't know why they put parabolas first, because parabolas are more difficult. So let's talk about circles for a little bit. Let's get into a technical definition. A circle is a set of points equidistant okay, so the same distance. That's what equal distance. A circle is a set of points equidistant from a point. And we call that point the center. And we call the distance that they are equal the radius. Okay, I didn't really put that there. Maybe I should have. So a circle is a set of points equidistant from a given point, so that all the points around it that have that same distance, that is it. First, we're going to talk about a circle at the origin with a center, center at origin. Well, that's just x squared. Let me see how I wrote that. Yeah, x squared plus y squared equals r squared. And if we want to graph that in our calculator, we need to solve it for y. And we would have to do a couple equations. When you solve this for y, you have to take the square root at some point. That gives you the plus and the minus. So y is equal to the square root of r squared minus x squared. And y equals negative the square root r squared minus x squared. So if you want to graph a circle in the TI-83, you need to graph a couple of different lines. Okay, that's very interesting. Groovy. So in general, if the center is at HK, okay, so I'm now no longer at the origin, I'm at HK. Okay, well, x minus h and y minus k. X minus h squared plus y minus k squared equals r squared. And that is a general equation of any circle. Okay, you need to know where the center of the circle is, and that's h and k, kind of like the vertex of the parabola. And you need to know the radius of that circle, but that's it. And then you can graph it using this equation, or at least talk about it using this equation. Okay, I actually want to go over a couple problems here. That's really it for the notes, but a couple problems, and the instructions will be the same for both. Find the center and radius. Find the center and radius. Okay, and here's a problem that's kind of already set up. X minus 10 squared plus y plus 9 squared is equal to 144. And I can just go from this form and tell you what the values are. The center, h and k, both have a minus sign in front of them. So both of them will change signs with this one. With the parabola, it was just the h, but both of them will change here. So the negative 10, h is positive 10. And the y-coordinate, negative 9. Okay, so look how easy that was. I just copied these two numbers and changed the signs. The center's at 10, negative 9. And the radius is the square root. This is r squared here. If you want to find the radius, you need to take the square root of that number. The radius is 12. Okay, that's not too bad. Okay, let's do one that has a little more gusto to it. Let me change colors. I've been using blue this whole time. How boring, right? Gosh, you were sitting there thinking, oh, I'm so bored. I wish you'd use a different color. Okay, I'll do it. Let's try x squared plus y squared plus 8x minus 10y is equal to 8. And we need to do that thing where we completed the square like we did with the parabolas. So let's see. Look at my x's together. Okay, you usually don't want to get your x's together. That usually spells trouble, but it's okay to do that here. Usually when your x's are together, that's bad news. Okay, enough of that talk. Now, you can see I organized this a little bit. I got my x's together and then I left some room. I got my y's together, and then I left some room. We're going to do that old mantra, divide by 2 and square it, divide by 2 and square it. Divide 8 by 2, well, that's 4, and then square it. Now, unlike with the other one, maybe I should have done that in a different color, plus 16, I'm just going to do it on the other side. It's easier to do that here. Okay, so I had a plus 16 on the other side. Okay, with the parabola, I put a minus 16 right after it while I'm moving that over to the other side. This is like a normal equation here. Again, divide by 2 and square it. Negative 5 squared is 25. Okay, let's factor this. Numbers that multiply to 16 and add to 8, there's going to be 4 and 4. Numbers that multiply to 25 and add to negative 10, that'll be negative 5 and negative 5. Beautiful. And what the world does that all that up to? 49? Oh, great, good. Okay, and just the fact that it came out to a perfect square makes me feel like I did it right. I feel good about myself. Groovy, it's great. Okay, so again, once I get to this point, finishing it off is incredibly easy. Opposite, opposite, square root. Opposite, opposite, square root. And that's it. So I gave you all your notes and a couple of examples. Look at all that good stuff you got there. That's great. Let's think some stuff for your left-hand side. I might have a GeoGebra thing. I don't know. I guess you'll just have to wait and see.